Hybrid Cloud Show, Episode 16. I'm Aaron.
I'm Gary.
I'm Sean.
And I'm Shane.
Welcome to the show about private cloud, public cloud, and everything in between. Our views here are ours and not those of our employers. So we've had lots of great feedback come in, so we're going to start with one of those. Jeffrey says, being an SRE myself, I often face a lot of interesting challenges within organizations that aren't necessarily from a technical nature. Things like how you get security to take a lead role on image scanning for the organization's clusters, how the SOC implements security monitors through the likes of NuVector, or how you assist your developers to leverage GitOps through Argo CD, Flux, or God forbid, Jenkins. I'd love to hear some experiences you lads have had yourselves, and any solutions you've come up with and are very proud of with regards to difficult challenges that you've faced. So shall we start with the technical part of that at the beginning? Or the expressly non-technical, I suppose that is.
Let's start with how to get people within your organization to take a lead role in something. And that comes down to you being an influencer. And that's kind of where you start getting up more like senior staff principal roles. You start focusing less on the individual code that you're submitting and more about the influence you're having on the technical direction of your company. And so if you are finding yourself constantly in this position where you want to engage with other liaisons from other teams to start forming better practices, better standards, better policies, better processes for your company, that's what being a lead engineer is all about.
Often I think it's about finding something that you know is a problem within the organization that probably applies more widely than your own team and finding a way to solve that. And then if your company has some kind of center of excellence or other kind of engineering guild, presenting that back as a solution that not only works for your team, but might work for other teams in a way that's scalable and manageable and all of those kind of non-functional requirements that we put across for most code.
I'd also say selling the benefits of the cloud in general is a good shout. You've mentioned an SOC, which for anyone who's unfamiliar is a security operations center. That can do a lot of heavy lifting in terms of scanning your cloud resources, but it might also be overkill and duplicating functionality that's already in the cloud. So perhaps getting your security team to take more interest in what Azure or AWS can offer to lighten the load might get them more interested and bought into your sphere of control.
I've had to deal with people having multiple registries, multiple places, like some in AWS, some in GCP, some in GitLab, some in a private on-prem one, right? How do you find a solution that works across all of those? And creating those standards and those processes does the kind of far-reaching consequences of the discussions we're talking about.
Yes, I think that there is a general question there of how do you get people to do things, right? And without getting all win friends and influence people on the audience, I think, you need to show there's a reason for people to care. I mean, that's the case with nearly anything, right? And then you build that group of people who understand the problem and you build your influence within the organization to be able to get that to somebody who matters. I know that's a very conceptual answer to a very specific question, but if you're talking about getting the security team to do something, then the point is that you need to show the value in the thing that you want them to do and show why it is that it makes sense for that to be solved in that central location rather than doing it within your own team, for example. And maybe by doing it in your own team and then doing it in another team, you can show that centralizing those efforts gets rid of some redundancy or improves something. But just asking somebody to do something is often a very difficult way to approach the problem because you're pushing the onus on them rather than helping them come to the conclusion that it's the right answer.
It's a common problem in platform engineering, particularly for companies that don't have platform engineers and are trying to kick that initiative off and sell it. Sometimes you'll need to sell these things to leadership. One of the patterns I've seen in the platform engineering community is people will go after something shiny to try sell something like leadership will get behind. So it might be like a portal that has a service catalog. It's not too invasive. It demonstrates some value perhaps, and it looks shiny and nice on a PowerPoint. And these might be some of the games you need to play to get your point across. If you have people you can escalate to support you in this, I think things will go a lot easier than being an independent contributor trying to change the sea of an organization, which can be really hard sometimes.
And sometimes I think as well, it's just about speaking to those teams and understanding maybe why they're not doing that. So it might be that they're assuming you're doing it. It might be that a SOC has other priorities, like maybe your company's getting denial of service attacked every day and they're kind of fighting fires. And maybe there's something that you can do to help lighten the load there. I've often seen that it's very easy to sit in one part of an organization and complain about what the other part of the organization isn't doing when you don't realize that the infrastructure team are running on a SAN that's end of life, or patching a VMware cluster, or whatever it is that you don't realize maybe as someone being an SRE.
Maybe there's a really easy answer here in terms of showing that value. If these container images are just sitting somewhere and you can scan them all yourself and show that you've been putting images out into production that have a whole bunch of vulnerabilities or issues, then it's much easier to have the discussion about how you should have caught those before they went out the door.
Yeah, and I think sometimes, like we've said, it's just being the change you want to see. Say, I've had it before where a company has been really, really stalled on a cloud migration. And I've just had a chat with leadership and said, hey, what if I were to just work nights this week and migrate some of these resources to the cloud? And then we can look at the performance increase versus running them on-prem or whatever. That's something I've done in the past where I've spent 2 weeks just moving an entire dev environment from on-prem into Azure. And suddenly developers are sitting there on a Monday morning going, oh, our dev environment's way quicker. Why is that? And yeah, you can prove the value that, okay, moving dev was relatively non-disruptive, so we can perhaps look at moving production or staging or whatever it is. So yeah, I think sometimes just like Aaron said, proving that there is an inherent value in doing that, or proving the problem with not doing that and not dealing with that technical debt or whatever else it is, often has value in itself. And that might be something that you do as part of a spike in a sprint or a spa day, as I've seen some customers call it. It's just something that you just got to take the initiative, I think, quite often.
And for Gary's example, that was within that person's responsibilities. It was time dedicated to a sprint during a spike, right? That's the right scope, the right time to do that. If you have something much bigger, like trying to tackle image scanning across 4 different locations across your whole organization, right? That's maybe not within your day-to-day responsibilities. Talk with the teams that are in charge of that and try to work with them instead of trying to do it all yourself.
Joey says, you've spoken quite a lot about Kubernetes, but what are some other tools that you can use to facilitate hybrid cloud in a modern workplace?
So aside from the obvious things of like virtualization and load balancing and all of the stuff that you would want to do to make something work across multiple clouds, one of the coolest things I've seen in a while and haven't played with as much as I'd like to is Open Function as a Service, which is effectively a replacement for things like Azure Functions or Lambda, where you just run Open Function as a Service, you write your Python or your Java or your Go or whatever it is, drop it into Open Function as a Service, and then you can really enable those event-driven workloads inside your existing containerized environment. So it runs on top of Kubernetes. I'm sure you could run it elsewhere as well. But things like that are actually really useful for taking some of those cloud-native concepts like Lambda and deploying them across multiple clouds in a repeatable way.
Yeah, I think taking a step back from that, there's all the other stuff that we talk about endlessly as well, like the infrastructure as a code, things like Terraform, things like Ansible, all those sort of pieces that make it easy to do multi-cloud in a way that would be much harder if you were doing everything specific to a particular place.
I want to take it one step further back. And I want to say, when you're trying to come up with a hybrid or multi-cloud approach, there are a couple components you have to bring together. The first one we always talk about is the platform. That's usually Kubernetes. It can be VMs, Open Functions as a Service. Great alternative. Yep. OpenStack, all these things. From there, you have to bring all those platforms together. So if you deploy one platform multiple places, how do you mesh it, all nicely together? And those are things like VPNs, transit gateways. Every cloud has a tool to kind of bring it over together. I mean, even some providers have tools like Google Anthos, where it's specifically designed to run a cloud instance and a on-prem instance, right? So bridging your platforms together, that's networking. And then, of course, when you do that, then it's okay, now where does my data live, right? My storage concerns. So once you have those 3 components all kind of figured out and chosen the best things and maybe talk to a vendor, whoever, to get that squared away from you, then we can start getting into the more details of what benefits do I get with this product versus this product. So those are really the three components to building a hybrid cloud.
I think there's so many different ways people approach it, even at a conceptual level, aren't there? I've seen people who keep environments entirely separate, but they are across different clouds or on-prem or whatever. I've seen things like you say, the Azure Arcs and Anthoses of this world, where you kind of keep it within one control plane, but you stretch the resources across clouds or data centers. There's things like Juju and Charms in the Ubuntu canonical world, where you are trying to model your application and then the cloud just becomes one substrate on which to deploy it, and you can integrate things across those. But I've seen so many different approaches that are all loosely multi-cloud or hybrid cloud.
I guess one question I have maybe for the group is like, Kubernetes is your default. Like whenever someone asks about hybrid cloud, we just say use Kubernetes. What is that second place? Like what's the thing where you'd go, I feel this is a safe decision to make because it's so popular and it solves a lot of edge cases I might not even be thinking about because it's used so heavily?
Databases seem like a very contentious point for Kubernetes. I've seen a lot of people who swear blind that you can't get the same performance out of a containerized database as you can get in a more traditional virtual machine. So I would say they are a bit of a holdout in terms of workloads that aren't being done as cloud native, though even that is not true for modern versions of things like SQL Server or some of the other databases that are being more containerized as time goes on.
I'm looking at you, Oracle.
I think for me, Shane, it's almost taking it back another level and rather thinking about how you orchestrate the workloads. It's how you build the applications in the first place. So I think there's a bunch of best practice there that your developers need to think about before you even start considering, do I deploy on Kubernetes or do I just deploy on something like a VM or a Docker Swarm cluster or whatever? It's how do we make the application API driven and all of the components loosely coupled and use things like message queuing or event driven architectures to really make sure that it doesn't matter if my thing producing my message queue is in Azure and my thing consuming my message queue is on-prem. You've got to almost think about it from an application point of view before you even worry about orchestrating.
Yeah, I think that is probably the most sensible approach because you don't want to engineer your applications around your infrastructure. Kind of wants to be the other way around.
It's both, right? Because I can't design something like with a cache if I don't have like a Redis instance available, right? So then I won't bring that into my application design. For example, we had a platform that did have Redis, but it was this weird active setup. And if I deploy my application with the Redis instance in one place, I was going to get it in the other data center as well. But that didn't really help me because I needed that shared Redis cache. So if I couldn't use that platform, then I had to think of a way around that. So I think it's a little bit of both.
Well, with the danger of making it even more complicated, it's almost you've got to worry about what the requirements are that the application has to meet before you worry about how you architect the application, before you worry about how you orchestrate it. If I think back to the time I spent working with some large gambling operators, there were certain parts of their workloads that they just could not run in the cloud. And it would be illegal for them to do things like store player wallets in the cloud, for example. So they would have to architect their application such that anything that needed to touch the database directly ran on-prem, but anything that needed big, flexible compute would run in the cloud. So there's almost that, what are the regulatory, legal, business constraints that you have to meet? Where do those components of the application sit? And then how do I build the application around those? And then what infrastructure do I need to support that as well? So it kind of goes pretty deep, doesn't it? It's way more than just, I want to use Kubernetes or I want to use VMs or I want to use a standalone database or I want to containerize the database. You're almost going back to, what is the core business problem that I have to solve here? How do I build the application to solve that business problem? And then how do I run the application in a way that's compliant with what the business needs? And I think that's the thing that we often forget about as engineers, because we all jumped very quickly to, how do I orchestrate this? What's the best way to run a container, or what's the best way to spit out an RPM that I install on a server somewhere? Whereas actually, it's almost working back from what is the thing, what business problem is it solving, and then how do we build it, how do we run it, are almost way down that tree of decision making, I would argue. You don't want to end up in a situation where you've got this really cool application that all runs in Lambda or Azure functions or has a Cosmos DB sitting behind it or something. And then you find, oh, I need to run this on some tin in a data center underneath a rock somewhere.
And everything you've said assumes that someone did, in fact, sit down and architect this thing properly, rather than it growing organically and horrible across the years in different places.
Yeah, and then you find yourself being the person having to unpick some of those horrible decisions that have been made that assume the application is always going to run on a single Red Hat box somewhere, which I think actually is probably the situation you're most likely to find yourself in, is you have this application that's been built over the last 30 years that assumes a bunch of things that you now have to try and decouple to run it in a more hybrid way, because business requirements have changed in the last 30 years. Suddenly, scaling is important, and people assume that they can go and sell the application into China tomorrow, and then suddenly you've got to run it in some highly regulated cloud or some environment that you're really not familiar with, or someone goes and sells it to a customer as a not software as a service solution, and suddenly they want to run it themselves on their own servers. So you find yourself in some very complex situations, I think, that make these questions really difficult to answer. So I guess maybe the answer is be adaptable as a person and don't be afraid of trying new technologies that aren't necessarily the ones you're comfortable with.
So if we assume that this question is kind of getting at what can Joey do to prepare the organization if it's thinking that multi or hybrid cloud is in its future, I think where we've concluded on the first piece is it's not normally good to start from the tools, and more you're trying to think more conceptually about the problems you're trying to solve and the requirements of the application. But assuming you've done that and you decide that there is a level of cloud neutrality you want to achieve, I think you go back to some of the things we've already covered. But shall we run through some of those very quickly to talk about the tools that Joey should be looking at?
Decide on a platform, Kubernetes, VMware, OpenShift, whatever you need. All your infrastructure as code. That's a big one. Terraform, OpenTofu. Storage. Where do we feel about storage?
Store as much in a database as you can, I guess, would be my advice. Unless it's objects or something, then put it in something that's commonly read-writable, which sort of brings you to something like S3 or something S3 compatible, I guess, is the real kicker there.
S3 is good. I mean, there's Minio if you want something self-hosted as an option later on if you want to swap clouds or distribute across them. So definitely S3 is a good shout.
S3, object storage, great. File storage is a little more complicated, but all the clouds have a solution for that as well.
API management is probably a good one to think about. So something like Kong or your other API gateways of choice.
Things like security credentials. I guess there's Vault.
And identity, dare I ask?
Yeah. If you're an enterprise, you'll probably have to look at Okta, Auth0, something like that if you're trying to do SSO.
There's still a bunch of stuff you're going to have to think about, even if you try and use some of these abstraction tools they write. I mean, I know we'd like to say that Terraform or OpenTofu is the answer to everything, but the reality is you've still got to understand the VMware module or the Proxmox module or the Azure modules or the AWS modules or whatever it is. Likewise, with you put Okta in front of everything. That's great. You've still got to write those underlying roles or underlying IAM policies for each cloud. So there's only so much you can abstract away.
This is a really hard problem.
Well, I think it's a hard problem for the whole industry, isn't it? Like this is something that the tools like the Jujus and Charms of this world are aiming to try and solve. But if you're approaching it piecemeal, then that's the whole problem, is you've got to take a whole bunch of individual components and you've got to integrate them into your logging, monitoring and alerting or observability stacks or whatever. You've got to plug them into your IAM stack. You've got to plug them into the different storage. Unless you have a consistent way that these things are thinking about and relating to each other, then those are all problems that you're going to have to solve.
And I think that is part of the difficulty of doing hybrid cloud, if you were doing everything in one cloud, you just make very opinionated decisions on the way that these things run. You probably use the cloud provider's tool of choice for a lot of them. And the problem almost goes away. I think that's part of why hybrid cloud to me is so interesting, is that I have to abstract away some of these things and still do them in a way that's just as friendly as AWS's observability stack, but that I can run wherever the workloads need to run. So I don't think there is a one-size-fits-all solution. And I suppose that's kind of what's cool about what we do.
So the question did say, it implied, are there alternatives to Kubernetes that Joey should be considering? Is our conclusion then that there aren't any credible Kubernetes alternatives? I mean, unless you want to go back to Mesosphere and so forth.
Well, I think there are a bunch of alternatives to Kubernetes. They just don't make it as easy as Kubernetes does. And I know using easy and Kubernetes in the same sentence seems a bit of a weird thing, but I mean, you could run it all on VMs. You could use something like Mesos or OpenShift or any number of other tools to orchestrate workloads at scale. If you really wanted to, you could run everything on VMs and have Cloud init scripts that go and pull an RPM from somewhere and install it. I've seen companies successfully do that at scale before. But I guess, yeah, if you want an easy, reproducible across the clouds, simple way to orchestrate workloads, Kubernetes is really the only game in town.
I think we talk a lot about Kubernetes, and a lot of the things we're saying as benefits really apply to the containers that are sitting orchestrated by the Kubernetes. And I think a lot of us are quite keen on the container instance runtimes that you can get on the clouds, or even going up that level, as Gary said, to the function of the service pieces. But in terms of the idea of trying to isolate your application into some contained unit, then it's hard to get past an OCI container of some kind.
Well, I think it's like I said before, if you loosely couple the workloads, the way you orchestrate those workloads matters less. We've made plenty of other suggestions on ways to orchestrate workloads, not least Docker Swarm, which got a horrible look from Sean, mainly because it's pretty much dead in the water at this point. But the key is looking at the workload and making the way that you orchestrate that workload less relevant.
There's been quite a lot of advances in the container space too, about things like, chiseling those or distrolessing them or all those kinds of pieces. But again, that's sort of staying within those same core primitives of a container or an OCI image. I think compatibility at this point is so important for so many organizations that going with something incompatible would need to have a pretty good reason.
Well, look at Red Hat. Like, Red Hat has their image mode now, which is basically make a VM, but with all the tools and advantages of a container. I mean, if you're not running a container, you can still use the tools, and I really don't know how much better from an application perspective you can really get than a container.
Particularly for hybrid cloud, I think containers might be the only game in town.
Yeah, I mean, if you're running in a single cloud, like using their functions and things like that makes a huge amount of sense, and I would probably pick that over a container if I had something that I just needed to run that took less than 15 minutes. Sure, go and throw it in a Lambda function or whatever, but that's very specific and opinionated to running a workload just in a single cloud.
Does it matter if Kubernetes is the only orchestration game in town?
It's not. There's OpenShift, which is basically just Kubernetes as it is. But yeah, it's all around container orchestration. Kids, don't do Docker Swarm. It's not good for you. It's not good for your health.
I think competition is good, though, and like bringing up new ideas about how these things could be managed. I mean, potentially we're closing off interesting avenues of how to manage this complexity in compute, but it's hard to answer that question without knowing what the other options might be if someone very clever was trying to come up with an alternative, a meaningful alternative to Kubernetes.
Yeah, I mean, I think that's the thing, right? Kubernetes has a lot of legacy and can be difficult to manage at times. And if it breaks, God help you, frankly. Like, having tried to recover broken etcd databases and things in the past, I just do not ever want to have to do that again. I guess it would take a big advance to knock Kubernetes off of its throne, because currently all of the vendor-provided products, like Sean said, effectively Kubernetes in a pretty frock. Things like Rancher or OpenShift or whatever are just a layer around Kubernetes that makes it slightly nicer to use. And yeah, likewise, I'm sure whatever a lot of the cloud providers are doing to orchestrate containers behind the scenes are using some Kubernetes principles as well. So, do I think it's a good thing that Kubernetes is the only game in town? No. Do I see that changing anytime soon? Also no.
So if we're done with self-help and Kubernetes and pretty frocks, shall we call it a day? Thanks for listening. We'll be back in 2 weeks. But before we do that, thank you to our existing PayPal supporters and patrons. If you'd like to join those people, you can at hybridcloudshow.com/support, where for various amounts on Patreon you can get an ad-free feed of either just this show or all the Late Night Linux family shows. And sometimes you get episodes early. Remember to share us around if you've got a friend who's interested in private clouds, public clouds, and everything in between. If you've got any questions or feedback, please do send it in to show@hybridcloudshow.com. And until next time, I've been Aaron.
I've been Gary.
I've been Sean.
And I've been Shane.
See you later.